Hi, welcome to this demo session of Cisco ACI microsegmentation for VDI users where classification of VDI endpoints is done based on Microsoft AD groups. My name is Ravi U. Krishna and I am part of Cisco data center team and work as a data center specialist architect. The objective of this demo is to showcase single policy plane, single security posture between data center and campus, and to showcase ACI microsegmentation for VDI users based on their AD groups. We will also see how this architecture benefits customers who want to move away with multiple VLANs based segmentation of their VDI infrastructure and instead like to see one flat subnet for deploying VDI desktops. Microsegmentation feature of ACI helps achieve all this with inbuilt security between the VDI desktop endpoints. The devices used in this demo and their versions are as shown here. The TrustSec integration with ACI and SDA provides a solution of interconnecting the administrative domains of Cisco TrustSec with ACI and SDA fabrics in order to provide a consistent end-to-end policy, rules, and segmentation. The integration between ACI and ISE for SGT to EPG bindings is through XXP, and for AD group microsegmentation it is through PXGrid interface. ACI is a PXGrid client registered to ISE server for PXGrid rated notifications. Campus network integrates with ISE for segmenting campus users to their right security group tags. We could map or bind a set of users to a single SG tag and have authentication and authorization policies pushed to that tag. This tag with policy information is sent in every packet which traverses the network, thereby providing a very secure network for users. The lab's network topology has two fabrics. To the right is campus SDA fabric and to the left is the data center ACI fabric. The Fusion ASR 1K router is provided for interconnecting both these network fabrics. It is optional in case both the fabrics are in the same campus or can be connected by dark fiber between them. Hello, welcome back. My name is Ravi Krishna and I am part of the Cisco data center team. In this part 2 of the video, we shall see how we set up various software components used in this demo such as Cisco ACI, Cisco ISE, Microsoft AD, and so on. In the end, we will demonstrate how a corporate campus user logs in to the SDA fabric, then gets access to the VDI server that is located in the corporate data center, and then gets automatically microsegmented based on his user ID and Microsoft AD group that he or she belongs to. So let's get started now. The Microsoft AD is configured on a Microsoft Windows Server 2012 R2 edition. So let us check the user and their group mappings here. Here we can see that we have two AD groups, namely MX and City. The users belonging to those groups are also listed. Now if we get into one of the users City User 2 settings, we can see the login name as City User 2 and that he is a member of AD Group City. Likewise, MX User 2 is a member of MX AD Group. Now let's go ahead and log into a Windows desktop computer as City User 2 user. Here we can see the user has got an IP address of 18.119.119, which actually belongs to the campus network. Now let's go ahead and log into the Cisco ISE software and see his SGT bindings. Under the Radius Live Logs page, we can see the user CityUser2 has been authenticated by ISE using .1x and is assigned with an authorization policy. He is assigned a secure group tag SGT of city_tag. Now let's check the configuration in ISE with respect to AD, ACI EPIC and Cisco DNAC. Microsoft AD is added into the ISE under External ID source page. Once we are in this page, we can see the connection settings to our lab network and the AD groups. These are the AD groups that are imported from AD by ISE. Now let's go ahead and check the SXP bindings that the clients of ISE has with ISE. SXP is the secure exchange protocol that clients of ISE use to communicate with ISE server. Under the SXP, we can see the EPIC and SDA fabric are registered as clients and are being mapped. Now, let's see where ACI is added into the ISE. This integration is needed for ISE SGTs to be automatically propagated to Cisco EPIC controller for SGT to EPG mappings. Each of these SGTs here appear in EPIC ACI as an external L3 out EPG with a user-defined suffix. As we can see under ISE ACI settings, we have an integration at policy plane control level and specify the EPIC out-of-band IP address and the SXP device or the domain to which ACI needs to be added. Now let us check the PXGrid services that the ISE provides and the clients that are registered for PXGrid notifications. Under admin PXGrid services, we can see that the DNAC and ISE Server 2 are the two clients that we will be using to demonstrate. Proper certificates needs to be registered among EPIC, ISE and CA server and DNAC, ISE and CA server in order for the communications to be successful. Now let us check the SGT bindings that are configured in ISE. Under Components menu, we can see that the security groups AMEX tag and city tags are created. These are the SGTs that are automatically sent to the ACI as external EPGs over SXP protocol. Similarly, the application EPGs that are created in ACI will be learned in ISE and will be shown here as learned from ISE from ACI. This is automatically done and the changes are propagated dynamically. Now let us take a look into ACI and see how we can achieve AD-based microsegmentation for users. Microsegmentation with the ACI enables us to automatically assign endpoints to logical security zones called endpoint groups or EPGs. These EPGs are based on various network-based and VM-based attributes. Microsegmentation with ACI supports virtual endpoints attached to Cisco AVS, Microsoft vSwitch, VMware VDS or Cisco AVE, the ACI Virtual Edge. Let us log into the EPIC controller and navigate to the AAA and Public Key Management menu. Under this menu, open Certificate Authority folder. You would need to import certificates from a CA server and save it here. And in the Keyrings menu, we create the certificate chain or cert chain and point the CA here. Now that the public keys are imported, let's go to the tenant configuration. I have a single tenant created for this demo called VDI tenant. Navigate to the services folder under this VDI tenant. Here we have identity server groups. In here we need to create a new identity server groups and add an authenticate server for authenticating with ISE. ACI communicates with Cisco ISE on PX Grid interface. All user logins, logouts and other policy information are sent over PX Grid interface by ISE to the registered PX Grid clients. ACI is one of the PX Grid client. ISE interacts with Microsoft AD in the background and captures the live sessions of the AD user who is authenticated and is trying to communicate or send traffic within the network. ACI uses this mechanism to classify the users to the right AD groups and in turn classify them under the right micro EPG based on attribute settings that are configured. Once the authenticated line is opened between ACI and ISE, we can see the domain and user info pulled into the ACI from ISE as shown. Next, let us take a look at how the application EPGs are defined and what functions they perform. I have created a single tenant called VDI tenant and have a group of EPGs under it. Common EPG is the EPG that will have all the common service requests and resources listed under it, such as DNS, DHCP, AD, etc. Server EPG will have Citrix VDI server configured in it. In my setup, Citrix VDI server and pooled desktops are instantiated on Cisco HyperFlex hyperconverged infrastructure. VDI desktops EPG will hold all the pooled desktop VMs in it. Note that this EPG is one flat network pointing to a single ACI BD and all kind of users coming from different AD groups get classified into this base EPG. This EPG is attached to a VMware VMM domain from where VM attributes and other info are pulled and populated. We are using VMware VDS for this demo. This base EPG has microsegmentation turned on to classify VM traffic based on the usage rules defined. Now let's take a look at the microseg EPGs created. We have two of them, city useg EPG to classify users belonging to city AD group and Amex useg EPG to classify users belonging to Amex AD group. Under city useg attributes folder, we define the rules for classification as shown. When choosing the attribute rules, we choose the classification criteria as AD groups. Once we choose AD group, we can go ahead and add AD controller that were previously defined as ISE server 2 and then add the AD domain as wipro.lab. Next, we go ahead and choose the AD groups that were defined in the AD domain, and this actually points to the Microsoft AD groups that were assigned to the domain earlier. Likewise, we configure the Amex useg with the classification criteria of grouping Amex users to their respective Amex group. Now that the configuration of all the components are done, let's do a quick demo to test our initial objectives. 1. Cisco ISE is the central policy engine between campus SDA fabric and data center ACI fabric. 2. ACI microsegmentation feature for classifying users based on their AD groups. In the demo, we will be showcasing an user city user 2 logging into SDA campus and gets city tag from ISE. Once authenticated from ISE, the user logs into the data center VDI server and opens the city VDI desktop allocated to him. Once he is inside the desktop, he can only access city resources provisioned to him, such as city web server, and not anything else. With that, let's get started. I have logged into a computer that is connected in the campus fabric as city user 2. The .1x authentication is successful and I have received an IP address of 18.1.1.119. The ISE live log sections, we can see that the city user 2 has been assigned a SGT tag of city_tag. Now let's log in to the ACI and under the VDI tenant, let's open external routed networks under networking folder. In here, let's navigate to the network folder where we can see all the SGTs that are dynamically learned as L3 out EPGs in ACI. Under city tag from ISE EPG, we can see the city user 2's source IP address that is being learned as 18.1.1.119. Now let's log into our base VDI EPG called VDI desktops and see all the VDI VMs that were initiated and learned under this EPG. When the city user 2 user logs in to the VDI desktop, we expect the user's endpoint to be moved or learned under the city usage EPG. Let's get back to our computer and log into the Citrix VDI server IP through Citrix NetScaler. We then enter the credentials of city user 2, which will invoke the storefront page, and the user gets associated with the VDI desktop allocated to him. Once the VDI desktop is opened, let's go ahead and verify the host name and the data center IP that the user has received for communicating within the data center fabric. Let's go back to the ACI and see if this user got classified under the city usage micro-segmentation EPG. The usage attribute rules based on the AD groups as shown here. Next, I have created a web server EPG called city web server EPG where all the city resources are provisioned. This city web server EPG has an ACI contract with web VDI city by which we allow communication between the web server and the city usage micro EPG that has city users in it. The city web server has an IP of 26.1.1.20 as shown. Now, from within the city VDI desktop, if we try and access this web server IP, it would be successful. There is another EPG created for Amex users called Amex Web Server EPG, and in there we have a web server resource with an IP address of 25.1.1.20. This web server has no contract to city users. Hence, from the city VDI desktop, if we try and access this Amex web server, then it will be unsuccessful. The same is shown here for reference. With this demo, we have showcased a powerful feature of Cisco ACI microsegmentation where the classification of endpoints are automatically done using Microsoft AD groups. We have also showcased a seamless communication and integration between campus and data center fabric that use a single policy matrix provided by Cisco ISE. I hope this session was useful and thanks for watching.